So nuclear fusion is the combination of two light nuclei to form a heavier one. Fusion is also a word we use for melting. It's a combination of things. I think of melting chocolate chips, right? The chocolate chips fuse together when they melt. Nuclear fission is splitting a heavy nucleus into lighter ones. Both of them highly exothermic because the products have higher binding energy per nucleon. Fusion is the energy source of the stars, not the movie stars in Hollywood, but the actual stars up in the sky, and it's the basis of the hydrogen bomb. So nuclear fusion, combination of lighter nuclei to form heavier ones. So there are two types of nuclear bombs. There's the atomic bomb and there's the hydrogen bomb. The hydrogen bomb is up to 1,000 times more explosive force than an atomic bomb. The atomic bomb has a tremendous amount of explosive force. Hydrogen bomb is just like mind-blowing. What happens in the hydrogen bomb is that you've got two isotopes of hydrogen combined to form helium. So you've got deuterium, which is the name for hydrogen-2, and tritium, which is the name for hydrogen-3, combined to form helium-4 and a neutron. In order to get this reaction started, you detonate a small fission bomb to provide the energy to get this started, and once you get this started, it goes by itself. So nuclear fusion would be super awesome as a power source, because look at the reactants and the products here. Do you see heavy metals that are radioactive? No. You're making helium. What's not to like about this? And it gives off so much more energy. This would be a great power source. 10 times higher energy density than fission, less problematic products. The problem is, in order to harness this, you have to contain it somehow. And there is no material that can withstand the extreme temperatures. This will melt or most likely vaporize anything that it's put into, okay? So it's not like you can put it in a crucible or a lead dish or something. The metals just melt. So that's a problem. The high temperatures actually generate a plasma, which is a fourth state of matter in which some of the atoms are ionized. So this is a picture of the tokamak fusion reactor, which is using magnetic fields to contain the fusing nuclei. So you can't use matter to contain this stuff because the temperature gets too high, but you can use magnetic fields. Now, the problem is that's a lot harder than it sounds. It requires a fair amount of energy as well. So any questions? It's just like a little teaser about nuclear fusion. It would be really, really awesome if someone could figure out a way to harness it. And there are people actively working on that, but it's a very, very difficult problem.